Hi, welcome to Tutor Think, and this is second order differential equation part 1. I have done a previous video under this topic. I spoke of all the solution types for second order differential equations. You need to watch that video to equip yourself with the solution types. This means that what are the possible solutions that you can generate for a second order differential equation depending on the roots of your auxiliary equation. If you don't watch this video to understand the concept of how to generate the solution for a second order differential equation, you will not understand this example, or you may not understand any question that you tackle under second order. So these are two questions that we are supposed to differentiate, but these are special cases under the solution type. The root of the auxiliary equation will determine the solution type for each of them. And we will find out that one of these examples will generate a complex answer where the real value is 0. And another one, each one of them will also generate a real value where the complex part is 0. So we will find out when we take this example. So let's consider the first example. We have d square y or dx square plus 5y equals 0. So we generate what we call the auxiliary equation. So the auxiliary equation becomes we represent the variable m with the auxiliary equation. So this is m square, which is second order, plus 5 equals 0. You don't bring this y. If you already watched that video, you will understand. So this becomes m square equals minus 5, since we need m, and root of m square equals root of minus 5. I need m, so this will take care of this. I'm getting m equals, let me move straight to, let me say root of 5 times root of minus 1, such that this time this will give me the same thing. Then root of minus 1 is the same as the complex notation I. So I have m equals plus or minus root of 5i. So I can rewrite this by saying m equals plus or minus I root 5. There's no need for you to change this to decimal notation. Now that we have gotten here, we have seen that the result, or the root of m of the auxiliary equation, was a complex number, but the real term is 0 because there is no real term. And if your root is a complex number with the real term being equal to 0, then your general solution will be y equals a cos, then you pick your root of 5, root 5x plus b sine root 5x. So no matter the value you generate here, whether a square root or not, so far as it's complex and the real term is not there, which is 0, then this is your final answer. You write that value, you take the constant a cos the value x plus b sine the value x. Forget about the positive and negative sign here. It's the square root that brought this here. And forget about this I, because the proof for this solution has made b to take care of this I, because this b is representing something. If you watch my other video, I proved all these ones for the person watching to understand the reason why the formula is like this. So b has taken care of this I and has taken care of this negative, and a has taken care of this positive sign here. So this will be your general solution for the complementary function that. And this is a special type of what question. We call it special case under complex numbers of second order differential equations. When the root of the quadratic equation generates a complex number that has its real part 0. So let's take the next example. The square y all over dx squared minus 4y giving us 0. So when we want to solve this, we generate the auxiliary equation. So our auxiliary equation becomes m squared minus 4 equals 0. And we have m squared equals 4. So when I take root of both sides, I'm getting root of m squared equals root of 4. And this will take care of this. Then m becomes plus or minus 2. Now, as we can see, the root of m was generating a real value, a plus or minus real value, with its complex term being equal to 0. So as soon as you realize that the complex term of this function is giving you 0 and you are generating a real value, then your final solution or your solution for the complementary function this will be y equals a cos 2. You bring your 2x plus b sin 2x, where this b has already taken care of this negative and this a has already taken care of this. The reason why we have cos and sin here is a proof, but I have already done that in my first video for this topic, so you need to watch that as I explained earlier. So this will be your solution, but you need to keep this in mind. You don't need to prove the reason why we have cos and sin here, and you don't need to prove the reason why you're supposed to have cos and sin here. But if you want to understand these things, you need to watch the first video to get a concept of why the general equation is like this, or the general solution is of this form. So the only thing I'll let you know, or I'll tell you to know, is that when the root for special questions like this, we call them special cases under solution types for complex roots. If the m is generating a real part, then it will be in cos and sin. You just bring the value, add x to it, bring cos a equals b. And if the root generates a complex value, then you bring cos and sin. The proof is in the video. If this video has been helpful, kindly subscribe to my channel. My name is Daniel, and I'll meet you in my next video under this same topic.